Okay, guys, greetings. This is just a walkthrough video of this particular test, the quarterfinal for Math 3. Okay, third quarter. First of all, rewrite this in logarithmic form. Remember, always start with the base. This is the 5, then kind of go in a circle, right? 5 to the power of negative 2 equals 1 over 25. That's it. Don't need to do anything else. Just rewrite it. Rewrite this in logarithmic form. So you're going to go log. The base is the 2. Make this a little subscript to make it obvious that that is the base. If it's bigger, I'm not sure if it's inside the log. The log base 2, and then go in a circle. 2 of 32 equals 5. Remember, the logarithm always is the exponent or the power. Okay? Now, consider these expressions. Remember, there are 3 rules that you're looking at in these kind of things, or actually these next 4 problems, and that's 1, coefficients like that and that and that and that and that, they all get pulled in as powers. So this is going to get pulled in as x to the 6th and y to the power of 1/2. So I'm going to pull those in first. Okay, now the other rule is that when you have a log plus a log, you go log and you multiply those insides. When you have a log minus a log, you divide. So this one, they're being subtracted. So I'm going to go log base 3 of x to the 6th over y to the 1/2. It's always the one that's being subtracted that goes on the bottom. Here, I'm going to start by pulling these in. What I mean by these is these coefficients, the 3, the 2, and the 6. It'd be x cubed, y squared, and q to the 6th. And now these are all gone, right? Okay, now I've got log base 2 of x cubed plus, so I know these are going to be multiplied, x cubed times this y to the 2nd, and they're all over because that's being divided the q to the 6th. Okay, there it is. Now the next 2 problems are just going to take this and go backwards. When I say go backwards, you start out with 1 log, and I'm going to end up with lots of logs. So kind of go backwards. In terms of these ones where we combined, we put the exponents up first and then we combined them. In these things, we're going to split them apart. So log base 3 of y squared. Now this is being divided, so I'm going to go minus the log base 3 of x. So if it's a division, these are going to be log minus a log. If this was multiplication, be a log plus a log. Last step, any exponents, pull them out front. So 2 times the log base 3 of y, the squared is pulled out in front now, minus the log base 3 of x, and that's done. This one, log base 9 of x to the 4th, but that 4 is going to get pulled out front right there. Plus, since these are multiplying, they're added, a log base 9 of y, and that's it. Okay, moving on. Solve. Now, this kind of problem, remember, on this kind of problem, I have an exponential equals an exponential. I want to solve those by rewriting this base to the same. So I think 16 is the same as 4 times 4, right? Yeah. So this is 4 to the power of x plus 1 equals 4 to the power of 2. There's the 16. It's still being brought to the power of 2x minus 1. Once these bases are the same, I just set the exponents equal to each other. X plus 1 equals 2 right there times 2x minus 1. So when I have a power to a power, I multiply those. So this is just x plus 1 equals 2 times 2x is 4x. 2 times negative 1 is negative 2. Make sure to distribute. And I get the x's together, and I'm going to end up subtracting x from each side. That's going to be gone. I'll add 2 to each side, and that's going to give me 1 plus 2 is 3. 4x minus x is 3x. And if I divide by 3, I'm going to get x equals 1. There. Now, this next one, x to the log base x of 127 equals negative 3. Whenever you have just a logarithm, and that's it, rewrite it. X to the negative 3 equals the inside, 1 over 27. Now this problem is a lot like this one up here. I think 27. 27 is 3 times 3 times 3, so 3 to the power of 3. And 1 over 27, well, a negative exponent would take it and put it under a 1. So 1 over 27 is the same as 3 to the power of negative 3. And now see, I have x equals x to the power of negative 3 equals 3 to the negative 3. So x is equal to 3, because that's the only thing that's different, x and 3. Now let me show you something else. And this you can only do with a decent calculator. So if you have an older calculator, this will not work. If this was a power of 2, you would take the square root. If there's a power of 5, you would take the 5th root. Power of 19, you'd take the 19th root. Well, what if I could do this? I could take a root with an index of negative 3. Holy smokes, you've never thought of such a thing. Now, a decent calculator will think about it. Check this out. There's a button somewhere in your calculator. It looks like that. It has a root where you can fill in the boxes. So if I go shift that button, see how there's a box to fill in the index? I put an index of negative 3 and 3 in there. Oh, not a 3, not a 3. It's not 3, it's 1 over 27. I'm sorry. I was going from right here. 1 over 27. There we go. So I would take the negative 3rd root here and here. There we go. And that negative 3rd root of 1 over 27. There we go. There it is, 3. So if I get to something like this, if I get to something like that, x to the power of negative 3 equals 1 over 27, you can think your way through properties of exponents and get down to here. Or if you have a good calculator, you can take the root with whatever index that is. Okay? Even your calculators are older will deal with a positive index of any number. But you need a pretty newer calculator to deal with a negative exponent. Okay. Let's look at this. A log equals a log. Well, that's easy. All you have to do when you have a log equals a log is set the insides of the log equal to each other, right? So then I'm going to subtract x from each side. That will wipe that out. I'll add 10, add 10. 3x minus x is 2x, equals 6 plus 10 is 16. Divide by 2, and I get x equals 8. Now, something that I didn't do on the last one, I did kind of think of it. 3. The rules for logs, you got to check your answer. I don't have to here because you don't need to check your answer on exponentials, but I have to make sure if I put this into the log, does it give me a negative number inside or a negative base? This didn't. This one, x equals 8. 3 times 8 is 24 minus 10. That's not negative. 8 plus 6, that's still positive, so I'm good there. So that's it. Next problem. Log plus a log equals this. Now, this is different than the problem we just did because here I had a log equals a log. Even if I moved this log over here, this 1 is in the way, so it doesn't look like log equals a log. It's going to look like log equals 1 minus a log. So that's not going to work. I can't just drop the logs. The only way to get these is to combine them using the rules we looked at down here. So I'm going to take the insides of those logs, and since I've got a log plus a log, I can multiply them. X plus 6 times x plus 2 equals 1. And if I expand all that out, I FOIL it together, in other words, I get log base 5 of x squared plus 8x plus 12 equals 1. That came from x times x, there's the x squared. 6 times 2, there's the 12. 6x and 2x, 6 times x, 2 times x, they combine to make the 8x. Now, I'm a lot like I was up here, where I have a log equals a number. So I just have to rewrite that as an exponential. 5 to the power of 1, which is 5, equals x squared, well, 5 to the power of 1, x squared plus 8x plus 12. Okay, I'm going to subtract 5 from each side. I and I get 0 equals x squared plus 8x. 12 minus 5 is 7. This will factor x plus 7, x plus 1. So I have this trinomial. I'm going to factor it. I set each of these equal to 0. Well, x is then negative 7. I'm going to come up here. Because negative 7 plus 7 equals 0. And x equals negative 1 because negative 1 plus 1 equals 0. So there's my solutions. However, I've got to check and see if I put a negative 7 in here, negative 7 plus 6, that makes negative 1. I cannot have a negative number inside my log, so negative 7 won't work. What about negative 1? Negative 1 plus 6, that makes 5, so I'm good. Negative 1 plus 2, that makes 1, so I'm good. So x equals negative 1 is my answer. This negative 7 is extraneous. Okay, these, I've got an exponential minus 2 equals 12. I'm going to isolate that. I'm going to do that by adding 2 to each side, and I get 3 to the power of 3x minus 6 equals 14. Now I'm going to rewrite it as a log. Log base 3 of the 14 equals 3x minus 6. Now that log base 3 of 14 is just a number. I'm going to add 6 to each side. So I've got log base 3 of 14 plus 6. The 14 is inside the log. The 6 is not. Equals 3 times x. I'm going to divide by 3. And I get x equals all that. X equals the log base 3 of 14 plus 6 all over 3. Now, if I want a decimal, now I got to use a calculator, right? So the log base 3 of 14 plus 6 all over 3, that gives me 2.8007 something, something, something. So x is 2.801 if I round it to the nearest thousandth. And I think that's what I was told up there, but I haven't needed to round it until then. Okay, there's solving equations. Next page.